Okay, so we need our rules for logarithms here. And the rule says that when I subtract logarithms, I can build one single logarithm instead of two. I can say log base 15. It's the same base, 15. It has to be the same base if I'm going to do this. So I can just write log once, and I'm going to build a fraction with 4 on the top, the first number on top. And the second argument, it's not just a number, on the bottom. So I'm going to have 2 over x on the bottom, and that'll still equal 2. Okay, so how do I resolve this this complex fraction? Well, I have 4 over 1. That's not much to think about. I know it's a 4. 4 over 1 is the same thing. But the 2 over x, the x is a big deal, so I'm going to take my least common denominator between the 1 and the x. That's x. If I had two different denominators, I'd have to find the common denominator. The least one would be the easiest one. And I would say, in this case, it's x over 1 on the bottom and x over 1 on the top. I'm multiplying by the least common denominator between the 1 and the x, and it's x. So the x's will cancel. And I'm going to be able to rewrite this as log base 15 of 4x on top. And since the x's cancel on the bottom, it's just a 2. And I don't have a complex fraction anymore, which is really great. And I go on here and I say the log base 15. I can simplify this a little further. The 2 divides into the 4, and I get just 2x is equal to 2. Okay, so what do we do now? Well, you have to remember what this means. When you say the logarithm, then you mean that this base right here, 15, and I can write this as 15, with the exponent that I'm equal to. Remember, a logarithm is an exponent. So this is my exponent for this base, 15 to the second power, should equal my desired result. That's my desired result right there. So it should equal that. If I raise my base to my exponent, I should get my desired result. Okay, well, 15 times 15 is 225. And that's supposed to equal 2x. Well, x must be pretty good sized. So I'll divide by 2 on both sides to find out what x is going to be. And when I divide 225 by 2, it turns out that it's 112.5. So x is equal to 112.5. When you do the one that you're assigned, this is the example problem, but it's not a very good example problem in one respect. Remember the exponent out front rule. This is for the one that you've been assigned. Let's say this is like the one on the bottom here. You realize that's the same thing as putting the 2, it's the exponent out front, I can bring it back in. And this is the same thing as log base 1/2 of 3 to the 2, or log base 1/2 of 9. 3 to the second power is 9. So I could rewrite that. I'd bring that exponent back in. And you have a base here of 1/2. This is all to help you do the one you're assigned. This has nothing to do. We're done with this problem. But we're just thinking about the one that you're assigned in classwork. And so if you get this 1/2 is equal to something. Let me make up something at this point. You get this base to some exponent, because that's what we did down here. We said the base is 15, and we raised it to that exponent too. So there was 15 to the second power right there. If you do this with 1/2 and you raise 1/2 to the exponent, and then you got something like this, and this is just purely made up. I'm just making this up. Let's say you got something like that, and you say, well, what do I do now? Well, let me recommend that you multiply the extremes here together and say x plus 2 times 1 is x plus 2, and that will equal, let me see if I can get a different color, that will equal the means here of the bottom times the top on the other side, and 2 times 7 is 14. At which point you can just subtract 2 from both sides, and you would say x is equal to 12. So This is just a random thing that I made up to show you how you could handle that. If that happened to come across your path in the problem that you're assigned, hint, hint,